All right, so let's talk about this one, ASM 104. Now what we're going to do is we're going to make a program that tries to triple things. So here I have a start. Here I have data. I'm going to have buffer in, which has some space, and then a buffer out that has some spaces. This is just area for input and output. So here I'm going to read up to 3 characters from the input and put it in buff in. Now I'm going to take the first byte of buff in and shift it left by 1, which would double it, and then add another one, so that should triple it. And then I'm going to put it in buff out. That's the plan. So if this, then I'm going to just write 1 byte of buff out. So this will take the 1 byte that came in, double it, add another, that should triple it, and then print it out. So let's see if this works. We're going to compile and run it. And I don't see it here, but I did it in the previous one. So let's go back to here. You compile it with NASM. There it is, NASM. And this is going to be 111. All right, and then LD it, which is here. So this has to be 111 and 111. All right, and so now if I do ls minus L, I have the source code, the object code, and the executable. So now I can run it, 111, and if I put in, say, a 1, I get a question mark. If I put in a 2, I get a question mark. If I put in an A, I get an unprintable blank character or something. So it's doing something, but it's not at all tripling this number 1 to a 3 or anything. So there's several problems with this code. And so if I do, now here's 222, and let's try this one. All right. All right, and the difference, the difference in this one is I'm going to have diagnostic printing. So I'm going to define a function called printC that will print the character in AL, the first byte of register A. So it's going to push it and move it here, and then eventually call a syscall 4, which is going to print it. So this is going to be able to print things. So now I'm going to print the character that came in. After I shift it left, I'm going to print it. And after I add 1 more, I'm going to print it. And hopefully by looking at all these, I'll be able to help figure out what the problem is. So let me compile this with NASM. This is 222, I think, right? Yeah, okay. All right, and then link it with LD. All right, and let's run this. 222. All right, if I give it a 1, okay, the input was 1. After I shift it left, it turns into a B. After I add another 1, it turns into here. Now, that's giving me a clue what the problem is. The 1 is not the integer 1, it is the ASCII character 1, which is 31 in hexadecimal, it's 49. And when you shift it to the left, that changes to like 90 something. And that's the fundamental problem here. So if you look at an ASCII table, you'll see what's going on. Here's an ASCII table. All right, so when I give it a 1 is here. That is the number 49 in decimal, or 31 in hexadecimal. When I shift it left, it's going to turn into 62 in hex, and that is going to be this lowercase b. That's why 1 doubled turned into b. So what you have to do is you're going to have to read a digit and then subtract 48 from it to turn it into the number you want. Then shift it and then add 48 again to print it out. That's the kind of thing you're going to have to do. And this is important as we go ahead, how to handle ASCII values and how they turn into real numbers in assembly code. So that's the point here. And that's what I wanted to show you. And there's a series of queries here where you get to clean this up. All right, so that's what I wanted to show you. Let me stop this.